Okay, so according to first Mulifebuna ones, yeah, thank you for you guys who are coming here for the first time. I think I don't really need to introduce myself. Mayitambasa na video, so you already know. So according to what we discussed in the group yesterday, we said that today some questions, and someone suggested that we do questions for set theory and sets of numbers, but I think we can also do complex numbers since question yama complex numbers is a fame usually mo paper, and I wanted us to be familiar with the past paper setup. So we pick questions apari set theory, sets of numbers and complex numbers past papers. So nga twaenda fe bwino, we should do about three papers that were fast enough. So we'll start from last year's paper, and this was from the last session. Kaidibade mbele sessions. That you know that baremba babaisa baremba bakwaisa group embi aremba different papers. So na imo for ikap mwakalembe paper imubonza. So you write session 1, you write another session comes a different paper, they write another session comes a different paper, right? That's how it will be. So I've sent the document that has these papers in the group. So we can start from there. We'll start in first over in the report last session, assuming that we've all opened this document. Have we done that? Okay. So potwalangira pali 2025. Remember the last thing. You know that it's the last session. So we'll start with question 1. Okay, so if you see Akambile Popa question 1, it's not really a difficult question. Okay, so that's the question in question 1, and they're saying using distributive and associative properties of sets, simplify. So we need to simplify this. Okay, so how we simplify this? First, twaditamba sama video on how to do this. Okay, it's not something new. Okay, so how we simplify this? We know that firstly we need to deal with this, the complement that is outside, right? We need to distribute it to what is inside these brackets. Okay, so if we were to do that, we know that this complement, firstly, yala is a color, fine. Jump here, and then it will interact with the union. If a complement interacts with the union will become what? An intersection. And again, it will jump and interact with the what? The x complement. So when it interacts with the x complement, realize that x complement, right? And we know that x complement is just what? X. Good. So what we will get will be x intersection, open bracket, y intersection z, then naka complement. Kakatsaikala apa. It's easy to see. So when we reach this point now, we need to deal with a complement. We need to distribute it to what is where? Inside. So kala is akashite interact na z. Z yaraba z complement. Which kala is akashite interact na what? na intersection yalaba union futhi kala isakashite interact na what na y yalaba y complement. So what we get would be x intersection y complement union z complement. That's what we're going to get, right? Yeah, so if you reach this point, the only other thing that you can do is you use the distributive property where you expand this, where you say we can write this as x intersection y complement union x intersection z complement. It can't go further than this. For some lecturers, it's not an issue, but it can't go further than this. Are we all good? Yes. Okay. So that was how you deal with the first one. The second one. Navuta. Nangunshe kwefi. Okay. Okay. Not kwishoku demboku. Okay. This question is coming from sets of numbers. When you start talking about irrational numbers, Kaidi, for sets of numbers, there are different types of numbers that you have there. You have the real numbers. You've got the natural numbers, you've got the whole numbers, and you've also got the rational and irrational numbers. And for irrational numbers, most of the time they'll just ask you to show that a given number is irrational. Pama irrational numbers, also very under sets of numbers, they only ask you to find to show that a given number is what irrational. So a type of question that comes like this for irrational numbers, it is usually the easiest. Ayesa mushupa abantu ni ali ayesa to prove that root 3 is irrational. Ayesa muku mipeta guys. Shiva mnafiro kuswata mana inga ni aja. Ama statement. Yeah. So, but in Gaisa, so Iranaka. Iranaka. So, if it came like this, we know that, so, remember my statement, guys. So, we know that we need to show that root 5 minus 1 is irrational, right? So we need to show that root 5 minus 1 is irrational. And we will show this by method of contradiction. So we'll show this by method of contradiction, right? And I think you also need to put, given that root 5, you need to put that, given that root 5 is irrational, you should put it there. You say, given that root 5 is irrational, we need to show that root 5 minus 1 is irrational. And we will show this by method of contradiction. So if we were to guess or to assume or suppose, we suppose that, we say suppose root 5 minus 1 is rational. If this root 5 minus 1, if it was rational, we know that it can be expressed in form of a over b, right? If root 5 minus 1 was rational, because every rational number that you're going to have can be expressed in form of a fraction, 9. Yeah. So if we assume that this is rational, then it can also be expressed in form of a fraction, 9. So we can also express it in form of, we can say root 5 minus 1 is equal to a over b. It can be expressed as a fraction. Okay. So once we express it as a fraction, the next thing that we need to do is we'll take this one to the other side, right? So we'll remain with 5 is equal to a over b plus 1. A over b plus 1. Okay. So if once we can do this, this is a plus b over b, right? You know what I've done here? So if you look at this is irrational, right? And we are saying that this is rational. So this is the direct contradiction. You can't have an irrational number be equal to what? A rational number. Remember, at first you supposed, you guessed, you said, you assumed to say root 5 minus 1 is rational. If root 5 minus 1 is rational, it can be expressed in form of a what? A fraction. And when we express it in form of a fraction, we say a over b, where a and b are what? Are integers. So where a and b, in short, a and b are rational. And we know that this is irrational. So an irrational number cannot be equal to a rational number. This is a direct contradiction. Have I lost someone? Now bakweba kalati kiri irrational. All of we all and that this part is what? Rational. That is what you have assumed. But for this part, for root 5, root 5 is what? Irrational. So you can't have an irrational number being equal to what? A rational number. That is a contradiction. So now how do you conclude this? How are we going to conclude this? Yes. Eh, ration. Eh, okay. Aisha ko. Yes. Eh, Okay. Yes, so you can end it like that as well. Someone else, how can we conclude this? Okay. So, so I've said that this is what? This is ration. This is a ration. So it's a since root 5 is a ration, it cannot be equal to to it cannot be equal to a plus b over a plus b over b, which is ration, which is ration, which is ration. Therefore, root therefore root 5 is equal to a plus b over b contradicts our earlier assumption. Okay, so this contradicts our earlier assumption, the assumption that we made for this step. So what you need to know is that if inalemba is not the only way that you can finish this. The key is the understanding. I've seen a paper. I think if you check one of the papers on Avika Kulika app, when you go kuma solutions, guys who wasangire enalembere ati he said something like root 5 is irrational. Root 5 is irrational and a plus b over b is rational, which this contradicts our area assumption. Badi mchonga. So you just need to understand if it on finishing this. I don't know if that's clear. Go try to look at your Nalanda guys. I don't know if you know where to find it. Chosen, do you know where to find it? Guys, Ah. Okay, so if you select MA110, then you go side kulia kumbali kulia klika side bar. You find paliapa about solutions. When you click on solutions, ayala kuletera test papers, tutorial sheet, shine. When you go my test papers, you find a list of papers there. When you click on 2022, here require documents na solution. I'll show you that after we are done. Okay, so I think we can move from this one, but try to understand what is happening here. Don't look swat up. Okay, so the next one is on complex numbers. Pali abashaliro navuta. Nafuta. Ah. You should pray that he can some test me and it is something that will look that will be similar to this. Not area root 3. Nango root 2 area. But yeah, ngaba like you for you guys. Okay, so we move on to C. C we have 1 plus root 2i over root 3 minus 2i. Okay, so we need to express this in the form a plus ib, right? That's the form that we need to express this in. And what that simply means is that you just have to, you have to rationalize the denominator. Okay. Rationalizing the denominator just simply means that you should remain with rational numbers, punch up. Fine. So if each, this is not a rational number, this is a radical. This is not a rational number, this is a complex number. So this is complex, this is radical. Okay. So both of these are irrational. So we need to rationalize the denominator, pasharama rational numbers. So how we do that is we'll multiply the top and the bottom of this with the conjugate of this one. And so what would be the conjugate of this one? Eh, plus 2i, right? That would be the conjugate. So we need to multiply this to the top and to the what? To the bottom. Mwalishi bana reason tuchitira multiply nishita tuchitira pe multiply punch pepeka. Do you know the reason? What's the reason? Chosen, what's the reason? Why don't we just multiply on the bottom? Oh, I'm sorry. So that it should be 1. Because you haven't changed anything up. If you do this, you haven't changed anything with the question. It's the same as we've just introduced 1. Because this divided by this will give you what? 1. So you haven't changed anything with the equation. But if you just multiply on the bottom, punch pepeka, you've changed the equation. You understand that? Good. So that's the answer I just gave. So that it should be this divided by this is 1. You haven't changed anything with the equation. Oh. Yeah, so you haven't changed anything with the equation when you do this. And trust me, you come to engineering. When you come to engineering, that's when you find that you need to introduce it into if you are Sophia River Common, where you introduce things but you don't change the equation. Yeah. Okay, so when we multiply with what? We multiply with the conjugate. For the bottom part, start with the bottom part first. So it's very easy. Me, what I like to do when I'm dealing with the bottom part is, I don't know if you've come across this. Is equal to a squared minus b squared. We know that, ka? Yeah. So, guys, tekwaba tikwete negative nga iberero kunyishpyapusa tafili in this form. Now, do you know that tiwap swapping iwa iletero kuiwa itwaliro? Yeah, so kutina ilemba so. In short, that's what I'm saying. I can write it like this. The inequate negative. Yeah, so I can write it like this. So I know that this would be my A. This would be my what? My B. So what I'll simply have then will be root 3 squared minus 2I squared. This will give me 3 minus, I'll get 4 and negative 1I, because I squared is negative 1. No one is lost. What is I squared? Okay, I'll get this. I'll get 2 to the power 2 times I squared. I. That's what I'll get. I know that 2 to the power 2 is what? 4. Right? I squared. We know that I squared is equal to negative 1. So this will be negative 1. So it will become positive. So this will be 3 plus 4, which will give me 7. Okay. So we've dealt with the bottom. Eh? Navuta. Okay. Bala njebeni hapa mulu, so that we don't waste a lot of time. What will we get on top? Since I've already done the bottom. What will we get on top? What will we get on top? Guys, what are we getting on top? Eh? Okay, simplify. This and this one. Oh, it's this. Oh, Philippa Wi-Fi. Oh, I see. I see. Okay, let's see if that's what I'll get as well. Guys, mwafira okufunya pamulu. Square root of 3 plus 2I plus square root of 6. I iri mukati na mkunzi. Okay. Lembero. Kubaya lemberero kwama iPhone. Anyway. At plus what? Minus 2 square root of 2. Like this. You should write it. The problem is these guys have any consistent. It's outside. That's why I've done this. These guys are not consistent because in the form A plus IB. It means that namuli question yabwama I bafile bali abikilo. Number tababa consistent, but anyway, you should just know how to. Doesn't matter. It doesn't really have an effect if ngawalembera I face to ngawalembera. Okay. Are we all getting this? Is that what you're getting, guys? Is that what you're getting there? Eh? Okay, let's try to confirm. So we are multiplying this, right? So we have 1 root 3 plus 2I plus root 2I plus I. Then you have root 3 plus 2I. Okay, this is what we have, right? It will just be like this. then this will be plus yala pera 6 root 6 naka I, then yala isaive 2 to be plus 2 root 2 this I times this I squared. Are we following? Yeah, so I times I squared, we know that it's negative 1, right? Yeah, so this would be chimwa chipali negative 1 up. So here is that we have root 3 plus 2I plus root 6I yalaba minus up. Okay, we good? Time and a minus okay. Okay, so but chosen but you have to correct for the first time. Opatwambira okushitanaani gani? Opatwambira okusangira. So pamulwa pa we have 3 plus 2I plus root 6I plus is it plus minus sign? Minus 2 root 2. Okay, that's what we have. Okay, so when you reach that point, what you need to do is if kwetama I fieka, neftafikwetama I fibepam. So when we group them, we'll have root 3 minus 2 root 2 I. Then plus 2I plus root 6I. Okay? And we know that this is over what? 7. But what we are going to do is we'll separate this. We'll separate this. Over 7. Over 7. I haven't changed anything. Anyone know what I did a perfect? What do I say? Guys, man, better feedback. Tira kukola. Tapadi. Okay, yeah. So nachita separate ama fractions. So if I separate like that, I can write this as root 3 minus 2 root 2 over 7 plus I will factor out the I'll factorize the I. So when I factorize the I'll have 2 plus root what? 6 over 7. Anyone lost? How I factored out the I? No one? So this is your A. This is, you've got your I hapa. Ichicha shallow quit. That's your B. Why monate? So nishi, when you write it like that, you've expressed in the form of what? A plus IB. Yes. So if we're to kubika a statement punch, you know the statement that you are supposed to put punch, right? You don't know. Okay, so you say that you're supposed to say 1 plus 2I over 3 minus 2I in the form A plus IB is okay. That's a statement that you're supposed to put punch. Guys, tamwa kwa nani kani? Ama marking like a marked paper. No, guys, You are just not using the app the way you're supposed to use it. I used to post about these things. Number Malibika group archive. No, seriously, you put the group archive. Like I collected ama papers ama student over marking up. And I posted that it's Okofili. Yes, I posted mu group that go and check out the marking, the marked some of the marked papers on the app. You ignored the. Eh. Oh, like that time when you were not paying attention. That time you never used to pay attention. I don't know why. So I'll post that again after this class. Okay. So I'll post it again. You need to look at how previous students used to answer before Taulalemba and Taulalemba tests. That's what you do. You need to look at how previous students answered. Even when you come to second year, you need to find that this wamana kwe paper yo bachonga. Tamula besh bama lecturers beno for bachonga. So at least get an idea of what bama final answers. You might know how to answer, but you don't know how to present your work. Okay? Yeah. So if everyone is done, tunafuta. Shitaila vutukana yena. Okay, so we're still on question one. Okay, we are still on question one. A binary operation. Binary operation it's the last one on sets of numbers. It's the last one. I don't know if you knew that. Did you know that? Which books have you been following that book? The Mathematical Methods by Mr. Sakara and the Mathematics Department. So even if you're watching my videos, that's the book that I follow, and I'm making the videos. So binary operation is the last one on sets of numbers. Sometimes, but I present what it's an independent topic, but it's under sets of numbers. Okay, so this binary operation on D. First, about how many binary operation ya bali bang. Guys, sama tawag tamo may binary operation. I didn't get. I've forgotten your name. Derek. Eric. Wipe them. Good. Your name. Jeremy Gueri P. Dennis. Okay. Derek Dennis. Okay. So consider the binary operation A star B, which is equal to A plus B minus 2AB plus B minus 2AB. Okay, where A and B are real numbers. We already know what real numbers are, I'm assuming. The first question on this binary operation is asking us to determine if the operation 2 star 1 would be apali A wabikapo 2. Apali B wabikapo 1. So that would be 2 plus 1
minus 2 brackets 2 times 2
okay, brackets 2
brackets 1.
brackets 1. More you guys in and you want how times in and brackets. More 9. So this is 3 minus what? 4. Okay, this gives us what? Negative 1. So this is 1 star 2, this is 2 star 1. From this we can see that 1 star 2 is equal to what? 2 star 1. Hence, star is what? Commutative. Hence, star is commutative. Anyone behind? Advance. Okay, hence star is commutative. Ngapi sana? Ngapi sana? Ngapi sana? Let's say yatsa format 2. When the yatsa number negative 2, this would have meant that this wouldn't have been equal. Hence, it wouldn't have been commutative. Okay, it wouldn't have been commutative. So, guys, remember that again, no one has seen a video of me solving this question on the app. Yeah? I don't know what the answer is.
So, you are supposed to pick any number?
Yes, real numbers. So you can put in, you can pick negative 1, or you can pick number 1 over 2. Number 3 over 5.
So what if we use 3 and 4 to give the same answer?
Yeah, to give the same answer. Actually, what I did after, when I was making the video for this question, now this is 1 and 2. All I have finished moving and I was like, wait, usually if you solve the equations with binary operations, you can tell me that usually the operations that they give you are not commutative. Usually, they are commutative. So I was like, let me do this again. So I made another video. I think I picked 2 and 3. Then again, I solved. So if you pick any other 2 numbers, if they have, if it's commutative.
So if we have meaning
not they have yet.
No, what I meant was, for example, we use 2 and 4, right?
Maybe it gives a 6 here, 6 here.
But it's supposed to be that side should be equal to that side.
If it's commutative.
It's commutative.
I will not remember it. Not remember guys. Okay. Okay, someone come and help me complete the last one. Last one. Please, someone come and help me complete the last one. Joseph. Yeah.
It's 1 star 2, right? Or 2 star 1? So when there's thing. Okay. When we have been taught to compute, it is the same as they have taught us to evaluate, isn't it? So when we are evaluating, we start with what is in the brackets, isn't it? Samwalisambirire Podimas ku grade 1. Whatever happened if in my brackets. Right? So we're going to begin with what is in the brackets. So this will be our A, this will be our what? Our B. And then
Okay, so to the one second, I think we are done with the questions that it's involved. The questions that we are involving what's this? Set theory and sets of numbers in this paper. Let's try to see if we can quickly go to the next one. Last time yali yatatu. I think nga teyabirinyisha yali yatatu. Yatatu. Although if you are unlucky wayayisanga muri session yo ikoserepo. Wayisa pisha session yamu nobe yachanguka. Guys, era bipa. Kuba fyo kuyafe muri session mu. Tetwe mubi. So era bipa guys. Because I can tell you, one of these sessions, I can tell that some question ya ishire pomuli session yali yamwike kira muri natulembe finde futa. Natulemba. Okay. Okay, good. This was the second session. So the second session. So what we'll do with this one is that so someone to come and deal with this first one. Hey. Kyrie, today we said that we only deal with the what's this set theory, sets of numbers and complex numbers from these past papers. Time here up. Someone to come and deal with this one.
So with this one, yeah, hello, hello. So for this one, so this is the. So whenever you see code, so maybe this is distributive. As opposed to put it in associative. So for you to put this in associative, as opposed to look for common things that are common. So things that are common here, you can see there is a intersection. So I'm going to put a intersection here. So for easy understanding, just easy understanding, you can cancel out these two. You cancel them out. So a intersection, open bracket, what's remaining here? We've got B union. Then any set union, its set complement is equal to universal set. Then any set intersection, that's intersection set complement is equal to empty set. So here it's going to be A intersection universal set, and anything intersecting universal set is the set itself, and anything union the universal set is the universal set. So here the answer is going to be A. Huh? Why? Instead of random invasion, two random oh, 5 days. Okay. So yeah, that's the one.
Okay. Do we have anyone who has a question? Daniel. Daniel, urejopa sana. Okay, yeah. So that's that. Nikana. Walilanda po pajaka sana. So the next one. We have Yama statement. Guys, behind my next one. Not remember one say. Okay. The reason I want us to end the share is because 16 hours. Mara is about second day. Those guys are serious when you tell them 16 hours, 15, 18, or 15 minutes. There's a serious. Mwala ba serious apa pen. Mute mtufi. We nishi mlepa irobili maziro. We. Okay, so we need to express this in the same what? In the same form. Right? This question, Ishibe, about Kabama complex numbers in class one. You've covered. The one pair of lecture question that is similar to this. Provide so Vaisa 12 if you have Kimisangire value for. Then what I did is Nadisanga Fendi. Why am but no, Gawa he was a good man. Very Pangama collection. Could have about maybe his tired. So I'm like, finish a red story. The chairman can afford it for it. Depends na direction of it. Is number three should get up. Well, guys, that one the one option. No, but sir, this is correct. This is correct. No. Which one be happen? Mwapepa kono. Before Tauraya. Guys, okay, so this one quickly to teach the nine. So we can see this one has got 2 now, can I mention? So what we need to do is we need to multiply it by the conjugate of this one and the conjugate of this one. Aye. So the conjugate of this one is 2 minus I. The conjugate of this other one is root 3 plus 2I. So these are the things that we need to do what? To introduce. Okay? These are the things that we need to introduce. So we need to say times 2 minus I. Then we say root 3 plus 2I. What you do punch na pamulifimo finai. Okay, so what you do pamulu, you also do na punch. So when you reach this point, guys, math is just about manipulation and understanding what you're doing. Do you know that I can pick this? Do you know that? You know that, sir? So what I'm saying is, what we will get from will be 2 minus I root 3 plus I. I hope no one is confused. Apo times 1 to Alashala Fenechichinai. Yeah, so upper, I can get these two, group them together. I get 2 plus 2 plus I, then 2 minus I. I get these two I. And I also get these two. Group them where? Together. So ngande form unaambira kuyolo na shariksha. Timothy. Do you understand that? Yes. So I'll start with this one. So root 3 plus 2I, then root 3 minus 2I. Okay. So if I write it like that, I know how I can solve this. I'll use that guide. Yeah? Achana. A squared minus b squared. So we'll use that property. Do you remember it where you said a plus b, a minus b is equal to a squared minus b squared. This is what we'll use. This will be your a, this will be your b. Now pafuti, this will be your a, this will be your b. Okay, so voila, solve so quickly in Japan, what this will give you? This namuchonzi. Guys, nesanga fast. 35. We will go for 35. 7. Okay, so this is your A, this is your B, right? So we'll say 2 squared minus I squared. A side line. This will give you 4. The I squared is negative 1, so it will be plus 1. Okay, you understand. This is 5. When you come here, it will be root 3 squared minus 2I in brackets what? Squared. This will give you 3 minus 4I squared. But we know I squared is negative 1. Alafu negative 1. Iyalaba plus. This will give you what? 7. So that's where now I was getting that 85. So number if you start manually, you don't have time for that. Don't have time for that. Okay. Now for Tefi. Okay, so since you told me that now for Tefi, what we are going to have will be 2 minus I root 3 plus 2I over what? 30. 35, right? Because this was giving us 5, and this was giving us 7. 7 times 5 is 35. Now we deal with the top part. Top part, this times this gives us what? 2 root 3. This one times this one gives us plus 4i, right? This one times this one gives us negative root 3i. Okay? This one times this one gives us negative 2i squared. But we know what I squared is. This is all over 35. We know what I squared is. I squared is equal to what? Is equal to negative 1. So we replace with a negative 1 here. Negative times negative becomes what? Positive. So this entire part becomes a comparable positive. Are we good? It will become like that. Okay. So katika pali stage, we know what we have to do. What we have to do is if kwetama I tufibike fyeka. If takwetama I tufibike fyeka. So it will be 2 root 3 plus 2, and we have plus 4i minus what? Root 3i over what? 35. And what I'm going to do, I'm going to split this. When I split it, I'll get 2 root 3 plus 2 over 35 plus 4i minus root 3i over 35, right? Yeah. So if I get that, what I'll do is I'll factor out I. So I'll get 2 root 3 plus 2 over 35 plus I, in bracket 4 minus root what? 3 over 35. Guys, nganimpangapo mistake pamokunjeba. Don't munentambaga. So you guys are there to be so it will be like that, right? Yeah, so it will be like that. You just put that statement that I said. Do you remember it? Yeah. Statement was, you said that 1 over 2 plus I root 3 minus 2i in the form a plus ib is 2 root 3 plus 2 over 35 plus I 4 minus root 3 over 35. Write like that. If you write like that, means you were done. Yes.
Is it possible to send out some
Of this, yes. Oh no! I made the. Have you seen my videos on how to find absolute values of complex numbers?
complex numbers?
Yes. There is a video. When you go for the playlist, Yama complex numbers, there's a video that shows you how to find the absolute value of a complex number and the square root of a complex number. How about finding the square root of a complex number? Eh? It was there. Yeah, I'm absolute value per. It's yeah. Oh, I see. Yeah. Okay, so are we good? Okay, what was the next one? Binary operation. People who share this one. Fast. This one is on binary operation. Let's share. You chosen now. Girls, you've now stopped leading. Yeah, now me. So what? Which one will you do? The first one. Okay, so come and do the first one. Then a different lady will come and do the second one as well.
So we've been told to question one is saying that is the operation commutative? Yeah, justify your answer. So here we said that if it is commutative, means B star A is equals to A star B is equals to B star A. So in this case, B should be equal to something like this. Yes. So here, now. So here we can find any two real numbers. So in this case, I'll use. So this is A, this is B. So our B is 2. Then here, our A is 1. So what is 2 to the power 1? And here what is 1 to the power 2? Not commutative. We try maybe it won't be Eh? Yeah, not commutative. Give a reason. Reason. Justify your answer. Aye.
So you showing that is actually so you
Oh,
say
what?
is it committed? Is it committed? You say it is not committed. The reason is no box.
Oh.
Are we good guys? Who has some food to eat? Chop chop. Where is our food?
So evaluate 3 star negative 1 star negative 2. So we're going to start with this. That's what Chosen said, if you remember. It's this, car before I continue. Okay. Ah, daddy. Oh. Eh? And then how do I conclude? Oh, that is close to that. This is close to that. I. Okay. Yeah. This we learned a long time ago in grade something.
Is this the answer that we're getting? That's the answer we're getting. Okay, is there any question? Which is sure? Yeah. Guys, let's see. Ewe. Vamusonda tabare kwabati the denominator is never negative. It can be anywhere apart from the denominator. No. Guys, look. Actually, mathematics here, we know. A denominator shouldn't be negative. Yes. Why somebody that mama guys? Very soon. Yeah, but that's the case. No matter what. Tabai posa abengi tabai posa kufia mano iru, but it's a rule. The denominator is not supposed to be negative. Okay, so are we good? Today Einstein 16 hours. Yeah, but it was second year. Okay, so we're done with this one. Can we go to 2024 sharp? You know where to find 2024? Yeah? Guys, the app. Derek, do you have the app? The website? 2024 yali fair biri. Barembere imoine kwata ama guys bali nombe chesa bali bakanya okusenda. I'm saying kwati barembere imoyi paper. Baba chitati barere mbaba nabo barerera pansi. Bare poafi baba chitaso.
So what usually happens in our push of the this paper
kuseni nomba kairimo guys kwali babali abakuba bati mwamba okulasangamu guys sharp Emmanuel ifwaye ni paper kwapo namuisanga guys ufuthi namulavation malama malamba okay. So hapa guys, hapa si B huko yaishiambia huko naikira hapa pa 2024 hapa baisamba kuingisha abantu abengi ila time yensi ifotwalefika feni pa group chat group F nga mwamukule mbafe bonse li paper limo mulepwira pa eh eh mami pera banga tabarefura sana kuno. Okay, have we found the paper guys? Bana nabata baisangi. Okay, so the first question is that using associative and distributive properties of sets, show that X union X complement intersection Y is equal to X union Y. I just remembered something. Okay. Okay, so we need to show that. That's the first question. So akana kanguka. So naraka sober sharp. So we know that in order for us to show this. Yes, sir. Oh. Oh, right, sir. It was my lecture second year used to take us in measurements. Was it measurements? Yes, it was measurements. Eh? Ati nindu fyanya. Oh, nyimfuni yako. Victoria. Oh, Veronica. Yes. Oh, you want to do it? Yeah,
Okay, so where? Okay, so this is the statement equal to x union y. So this is what? Distributive law. So x union x complement, this is what I've written here. The intersection brought in the middle, x union y. So we know that x union x complement will give us the universal set. So we have the universal set, intersection, the set, x union y. So once we just see this, we know that the answer here is that. But you can also do the same thing that you did here. So it will be universal intersection with x set union universal intersection y. So universal intersection x will give you x, union this will give you y.
Eh? Eh? Okay, so now to monofilian, you've seen the way it is. So what we first need to do is to expand the sign. We need to firstly expand this. So we'll multiply chichiri kunsi. So we'll distribute. That's what we say. Distribute this to what is in the inside line. So we'll get x union x complement line. That gives us this. Then you have our intersection there. X union y complement. That's what you get here. So you just distributed. We get that. We know that x union x complement will give us the universal, right? Same na filiato chikwata at b union b complement, which gave us also the universal. So fyaliba universal. Fyaliba universal. Yeah, so from there, you can either simplify it in this way or simplify it in this way. Which either way you'd like. If you want to expand again, we know that any set when a set is intersected with a universal set, your answer is just that set, right? So, okay guys, I think so should I do the next one or should someone come and do it? Pasha watching. But Derek, you know. As my boy said, guys. Sharp, sharp. Oh. Molo ampula, guys. Molo ampula. Step sharp, sharp. Yeah? Okay. Sure.
It's not this. It's not the one. One, two. Which one? Oh, question. Oh, this one. At express x equals to. This one. in the form max. So there we say let x so here we all know that we need first to multiply by 10, right? So we say 10x 10x. So we multiply by 25.90 like that. Here 100 x by it will be 25 since 10 is here 90 like this 0.90, so it will be like that. So it's enough. No, should be like this. Point two. Since this is going continuous this side, so 90 should be something like this. Yeah, like that. Get back over here, right? So since it's not matching, multiplied by 1000, so it will be 25 90. So now we can subtract. So we say we subtract this one, we subtract this from this one. So say minus 10 10x, choose 25. So there it's, you know that it's 0, right? There it's 5, it's 6, 5, 2. And then 1000 minus 10, 990. Like this. Is it right? Correct? Is it correct? 990. Oh, yeah. Yeah, like this. So say x 25 65 over 990. So the number which we can divide first 3. Let's try 5. 5 and 9. It's 1, 4. 5 and 49. It's 9, 5. So 5 5 into 25. It's 5. 5, 33. Upon like this. Wait. 5, 5. 5 into 65. 5 it's 518. 5 into 25 it's 5. 5 into 6 is 1. Remainder 1. So 5 into 15 is 3. So it will be 518. Then 5 into 9 it's 1. Remainder 4. 5 into 49 it's 9. Remainder 4. Into 40 it's 8. A number which can go into 518 and let's try 3. 3 into 5. 3 into 51. No remain. 3. So 17. 17. 21. 3. 17. So to 171. 3 into 19. 198. Into 15 into 5. So 6. So 6 remainder 1 into 18. 6. So here it's 6. 6. So 66. So it will be 171 over 66. A number 3. 3 into 17. It's 5. Remainder 2. 2 into 3 into 21. It's 7. So it will be 57 over 3. It's 2. 3.